All right, guys, welcome back. In this video, I'm going to be talking a little bit about specific, I guess, kind of a specific sort of function, um, reversing numbers. Now, in the fourth Euler problem, I did something where, and I think I did it, separated out by lines, but it's something like you get a number. So let's say const num equals 1 2 3 4 5 6 7 num dot to string split dot reverse dot join, and that will give you the reverse of the original number. And technically, if you want to keep that as a number, you need to wrap that in a parse int, because at this point it is still a string. Unfortunately, there is no method for reversing a number like that. So if you want to reverse a number, you either have to come up with your own function or use what we just did. You might notice that this is going to take a bit. I wonder, does this log the time? It does not log the time. That's okay. We can look at that a little bit later on. This is going to take a while. You're converting it to a string, you're splitting it, you're reversing it, you're joining it. I'm not too sure on the complexity of that. It might be n, but it's at least 4n, right? So what if we want to make that what if we want to make that go a bit quicker? Let's take a look at that right now. So equal 0. So as always, what are we doing? We are defining our function, and then we are setting our what we're going to return. We're not returning the original. I guess we can return the original number. It wouldn't. It's going to be easier if we don't, though. What we're going to do here is we're going to loop through. We're going to loop through this number, and we're going to take there's a specific way in which we can take out that final number and put it in front of another number. So we are going to, well, we got the result there. So while that original num is greater than 0, what are we going to do? We are going to say that the result is equal to n times the result plus num modulo n. Okay, so finish this up. Math.floor num divided by 10. Okay, so what's going on here? So we've got a result right now. First go around, this is 0. So 10 times 0 is still 0, plus num divided by the remainder of num divided by 10. If we take this and divide it by 10, we have a remainder of 7. So result is now 7. Then we take num, we divide it by 10, and we round down from that. So what is that going to give us? Num is now equal to 1, 2, 3, 4, 5, 6. So result is equal to 7. Num is equal to 1, 2, 3, 4, 5, 6. Go round again. 10 times result. Now that's 70. Num modulo 10, that's 6. 76. Num equals math.floor, etc., etc. Now it's equal to 1, 2, 3, 4, 5. So here's what's going on. Sort of a sneaky way, we take each time we're taking that final number and we're pushing it to the front of another number on the next go around. Meanwhile, we're chopping that final number off at the end of each phase because we've already pushed it into the other number. Because we're dealing in base 10 units, we are dividing by 10. Technically, if this were hexadecimal, we would divide by 16. Well, you wouldn't write it as 16 necessarily. You would write it as different. I'm not sure what the hexadecimal format is, like F or something like that, right? Actually, I guess it's still 10. Or if we were dealing with something like base 8, it would be, I guess it's still represented this way, but it's going to mean something different. And then we've got to go around and divide it and get to get the new number that we're going to want to pass in. Once we're done with that, we can return the result. So let's take a look and see what this looks like. And we should get the exact same answer. Console.log get reverse. Can't auto finish on this. I shouldn't have named it string. I should have named it get reverse num. And then let's pass it in num. There we go. We're getting the correct answer now. So that's how you do it. And this is going to actually, relates back to that Euler problem number 4. Let me see if I can go ahead and pull it up. Right, so this was the original prompt on the palindrome. And the code that we had, you'll notice this is what we used. That's what I used at the beginning. I think originally I had these all split up into 4 different lines, which is frankly way too much. We don't have to do that, though. We can just define the function that we've just done right here and say reverse product or equals get reverse num. And if we run that, we will notice this second one goes a whole heck of a lot faster than the first one. And the only real difference is this line. I think there might have been a few changes that I had made since showing that originally. But those were all fairly minor. And those changes are now reflected in both anyway. So if you'll recall, what we do there is we are looping through the numbers each time, making sure that they are, so we start out at 999 times 999. We check to see if those are equal to each other, or if the reverse of that number is equal to the product of those numbers. If it is, then I was storing it in an array last time. Now I'm just storing the highest value. And then we just start counting down, and then we have to reset j every time we're done with j, because when we're done with j, we're also done with I. We've got to go back to a new number of I and go to a new number. We have to restart j then. So this is going to obviously improve your speed on that drastically. And it also is going to provide you a level of safety in, not converting types, right? We're only dealing with numbers in this instance. Whereas in this instance, we start with a number, we're converting it to a string, then we're converting it to an array, and then we're converting it back into a string. And we never convert it back into a number. If I wanted to convert back into a number, I'd have to wrap this in a parse int, which is why you'll notice here, this is the color for strings in Bash, and this is the color for numbers. So this is going to help protect against accidentally coercing a type into another type without knowing it. And if you're not careful, I mean, this is a great instance of trying to manipulate a number to do something, but to manipulate it, oftentimes you either need to write your own code or rely on methods that are going to put it into a string, put it into an array, etc. So I hope you guys enjoyed this video. Obviously, with this new knowledge, you guys should check out, see if you can do Project Euler a little faster. And I'll see you next time.